Welcome to the Crazy Hat Chemist. So another video here on acids, bases, and titrations. Here we go. Bam! So today we're talking about the stability of complex ions. Okay? Transition metals with ammonia form stable complex ions. So what is a complex ion? Here's an example. We got copper ion, that's the cupric ion plus ammonia, 4 ammonias, and it yields a product of a complex ion. This is a complex ion right here. That is the copper with 4 ammonias. Still, since ammonia has a net zero charge, then the complex ion charge is still the charge on the transition metal cation. Hopefully that makes sense for you. Okay, the Kf of this is 6.8 times 10 to the 12. This is the constant for the formation. That's why it's a Kf for a complex ion. So the Kf is a formation of the product of that formation. Okay, and these are all product favor. That exponent is greatly positive. Okay, dissolving of some solids, i.e. precipitates, can occur with the addition of ammonia to form a complex ion, especially with transition metals. Since the complex ion formation is typically a very product-favored reaction, it will drive the reaction forward more than it was before. Okay, so here's an example. That is, silver chloride is a solid insoluble precipitate. It is an equilibrium reaction between its solid and the ions of silver ion and chloride ion. And it has a Ksp of 1.8 times 10 negative 10. And this is the solubility product constant. In the next unit, we're actually going to be talking specifically about solubility product constants. But the concept here is the same, products over reactants with the stoichiometric coefficients as exponents. And you do notice that there is a solid here, so this has no denominator in this term for the Ksp expression. And that is very reactant favored. Notice that exponent is negative, so it is very reactant favored. Okay, here's the complex ion formation of silver and ammonia. Gives a silver ammonium complex ion. Has the same charge as what the silver ion does have as well. And this is a K of formation, just like we did before. Up above with the copper, it's a transition metal cation. Okay, forming a complex ion with ammonia and silver. Okay, the K of formation of this is 1.6 times 10 to the 7, and that's a positive 7, so therefore this one is a very product-favored reaction. It's not an equilibrium. We're going to add up these two here, and we get the following equation, which is the silver chloride solid plus 2 ammonia in equilibrium with the complex ion of silver and the ammonia plus the chloride ion. This will give me a K net for this equation. So if you remember back to the equilibrium unit, when we add up equations, then what do we do to the K's to get the K net? Well, we have to multiply them. So the K net is the Ksp times the K of formation. So we're going to take 1.8 times 10 negative 10, multiply that by 1.6 times 10 to the 7, and we're going to get this value right here, 2.9 times 10 to the negative 3. Now, I should point out that this is still reactant favored, but it is most certainly more product favored than it was before. Therefore, with the addition of ammonia to a silver chloride precipitate, you're going to actually draw some of that solid precipitate out of the precipitated form and remove some of it and form a complex ion. That will drive the reaction forward a little bit more. It's not as reactant favored, a little bit more product favored than what it was before. Okay, here is a great bumper sticker, especially for scientists. Okay, scientists do it repeatedly. Okay, and you know that scientists have to repeat experiments over and over and over again, right? Just like any kind of profession, you are always doing the same job multiple times, no matter what it is. And here's a few examples of some scientists. Oh my gosh, you know who that person is. And of course, they were picking the wrong brain because they picked the abnormal brain. But these are some real scientists right over here. Okay, I used to work in a lab a long time ago, and here are some real scientists doing real science. Okay, hopefully you become one of those real scientists in the future. Okay, you follow all my videos, it will give you a great foundation of the chemistry that you're going to need to know because you are going to be using it someday because it's most certainly useful. Okay, I am the Crazy Hat Chemist, and of course I got a crazy hat, and I got bumper stickers and t-shirts. Yeah, you gotta get me some of them, baby. Give me a thumbs up if you like that video, subscribe to my YouTube channel, and I'm gonna see you next time for more cool chemistry videos. Bye for now.